Do you know long division when we want to divide two polynomials?
Yeah.
Okay. So now let's consider, for example, p of x is x to the 6 minus, for example, x to the 5 plus 3x minus 2. And now what's problem is this? P of x is this one. What's the remainder when p of x is divided by choice A? X minus 1. I think you know this. This is the easiest part. Calculate part A.
Is the remainder 1?
The remainder is 1, you said?
Yeah.
Yes. Can you explain your solution?
I did synthetic division.
Uh, you've divided, right? Long division?
Like
Yeah.
synthetic division. I mean, it's kind of like long division, but kind of different.
Uh-huh. You mean in a line you write x minus 1, then you find other terms? Huh.
It like looks like this.
Uh-huh. You solve it this way. Okay. I will tell you a faster way. Let me. So this one is one correct. Let me check. You know how to calculate. Next one. Next one is x squared plus 1. See, can you calculate this with your method?
I don't think I should do it. That one's only for let's see.
When the degree is 1. Okay, so want to try part B first on your own or one hint? Try a bit on your own because I want to see can you calculate, then after that when I tell you solution, because I want to tell you different approaches, different solutions. Okay, so try a bit on your own. See can you solve it. One hint.
Is it
Or
2x minus 3?
it's what? 2x minus 3?
Is it? Yeah.
Okay, let's check. 2x minus 3. I want to tell you different approaches for solving these types of problems. First one, I will explain for part A, then we will use same approaches for this part. First solution is what? We can use, for example, long division, right? X to the 6 minus x to the 5 plus 3x minus 2 divided by x minus 1. So we can place x to the 5, right? So it will be x to the 6 minus x to the 5. It will be what then? If you subtract, this one will be cancelled, this one will be cancelled. It will be 3x minus 2, right? Agreed?
Yeah.
Then you can add 3x minus 1. So it will be what? 3x minus 3, sorry. 3x minus 3. And then minus 2 minus minus 3 is 1. It is first solution. Solution 2. You can say x to the 6 minus x to the 5 plus 3x minus 2 is equal to x minus 1. Then you try to create, you say, okay, x to the 5, x to the 6 minus x to the 5, then plus 3, 3x minus 3 plus 1, right? Understood both solutions? Or want me to explain? If you want, I can explain any of them.
Oh no, I understand.
Okay, now solution 3 is important. Solution 3 is what? Suppose, for example, we divide two numbers. Like what? For example, 23. When we divide 23 by 6, for example, it will be what?
Um, 5.
5. It's, if you say 5, then 5. Yes. Remainder is 5. Yes, yes. Remainder is 5. Yes. So do you agree we can write 23 is equal to, when we divide 23 by 6, it's 6 times 3 plus 5, right?
Yeah.
So we call 6 divisor, right?
Mm-hmm.
We call 5 what?
Remainder.
We call 3 what?
Quotient.
We call 23 what? Dividend.
Dividend.
Exactly. So in general, when you divide a by b, for example, it is q, bq, you subtract it's r, then a is bq plus r, right? And a is again dividend, b divisor, q quotient, r remainder, right? So when we divide, we have one condition. The condition is what? When you write this. Remainder. Remainder, yes.
Divisor.
Is less than absolute value of divisor and greater than equal what?
0.
Exactly. Remainder cannot be negative, okay? It's a non-negative number less than absolute value of divisor, okay? Now we have same thing, similar thing when we have polynomials. So here, let me move it, this part. Okay. As you can see, x to the 6 here, again, it is like this one, 23. You can say x to the 6 minus x to the 5 plus 3x minus 2. You divide it by x minus 1 divisor. Quotient is what? X to the 5 plus 3. And the remainder is 1, right? Agreed?
Yeah.
Okay, now let's write general form, like for numbers that we wrote general form. So let's write general form. Suppose we want to divide a of x by b of x. So we can say a of x is equal to b of x times q of x quotient plus remainder r of x, right?
Yeah.
Here we had a condition. Remainder should, for numbers, should be at least 0 at less than, strictly less than absolute value of divisor. Here again we have a condition similar to that. Do you know the condition is what?
Or is it like the degree of the divisor
Degree of remainder
is
should,
smaller
should be less than degree of what?
divisor.
Exactly. This part is so much important. We want to use this for solving the rest of problems and also AMC problems. And now let me tell you something. If p of x is equal to 0, do you agree we can conclude left hand side a of x is equal to what? This part will be 0. Do you agree it will be equal to r of x? Okay, let me draw a box. This box is the most important part of our lesson. We want to solve all problems with only using this, okay? It is the background idea. Part A, I will show you. Background idea of part A is this. Background idea of part B is also this. Background idea of also harder problems in AMC, AME is this, okay? So these background ideas are important. Now let's see how we can solve all of them with only these bugs. Okay? Okay. I want to solve first part A that you could solve with these bugs. Then I want to solve again part B with these bugs. Let's see this one. Here, when you have something like this, at first I write complete solution, but after that you can solve it in 5 seconds because you don't need to write all these things. You can imagine them. But for first time, it's good to write. I say, okay, here we want to divide this. X to the 6 we want to divide by minus x to the 5 plus 3x minus 2. I want to divide it by x minus 1, for example, times q of x, I don't know q of x, plus r of x, right? Now, the condition is what here? In this box we have a condition. The condition is what?
The degree of the remainder is
Yes, degree of remainder, r of x here should be less than what?
1.
1, exactly. When it is less than 1, means r of x is what? Degree of r of x should be what?
0.
Exactly. So let me write first this. Degree of r of x is 0. When degree of r of x is 0, means r of x is what?
Big number constant.
Exactly, a constant. And now let me move it to, let's move this to one page. Okay. So let's move this. Now, here I know I said we should check what we know that if b of x is 0, then a of x is r of x, right? Here we said, right?
Yeah.
So b of x is this. If x minus 1, 0, then x means is 1. Then this part is what? This part is our a of x. So a of 1 in this case is equal to r of 1, right?
Okay.
A of R of 1 is what? Is our remainder C. A of 1 is what? You should replace 1 here. 1 minus 1 plus 3 minus 2. 1 minus 1, 0. 3 minus 2, 1. So remainder is 1. So let me tell you, when you see this problem, for example, for next time, you say, okay, x minus 1, I should divide by x minus 1. So x minus 1, 0. X is 1. Let's replace x1. It will be 1 minus 1, 0. 3 minus 2, 1. Okay? Okay, now let's see how we can apply this for harder problems like this one. Again, I say what? A of x, our A of x is what? Our A of x is this one. Okay? Our A of x is this one. I want to divide it by x squared plus 1 times q of x plus r of x. Okay? Now for this one, we should solve this one to get good at these types of problems. And then you can solve part C, D after solving this. So try this one a bit on your own, okay? Then after that, if I tell you solution, it will be better. Try this one a bit on your own. See, can you find remainder by this approach? Okay, that's okay. Let's now try to solve this one, okay? You, you can say it again?
Like, can you do like 100?
Oh, okay, sure.
Oh yeah, I got it. It's still 2.
Ah, good job. So let's try now this part together. Here in this case, we know that degree of R of x is less than what?
Is less than 2.
Yeah, so we know that R of x is what? General form of R of x.
Something x plus.
Yes, ax plus b, right? Okay, now here again the most useful idea is this x squared plus 1, 0. You can say, okay, x squared is negative 1, right? So when we have x to the 6 plus this, we can replace all x squared with negative 1. So it will be x squared cubed minus x squared squared times x plus 3x minus 2. X squared is negative 1. So it will be negative 1 cubed negative 1 minus x plus 3x minus 2, which is 2x minus 3. Good job. You solved it this way?
Yeah.
Good job. Yeah. Uh-huh. Good job. And let me tell you something. Here we understood that an R of x is unique. We understood that it has this form. So if here you had x squared something x squared, again apply this. Okay? You should apply x squared equal to negative 1 to reach a degree less than 2. Okay? Now let's try to solve one more part. After this, we can solve AMC problems. X squared, suppose our polynomial is this if we divide it by x squared plus x plus 1. Okay? Try this one. Again, with the same approach we want to solve. Try first on your own. One hint for this one, or wanna keep trying?
I wanted to play.
Okay, sure.
Is it 4x?
It's what?
4x.
Can you say it again? 4x, you said?
Yeah.
Okay, let's check. You said 4x. Let me tell you two solutions, but both of them are related to this approach, this box. Solution 1. I say x squared, again, I should consider x squared plus x plus 1, 0, right?
Yes.
So I can say x squared is negative x minus 1, right?
Okay.
Okay, so you can say what? Solution 1 is a bit longer, solution 2 is so much easier. So let's apply first this one. Here it is x to the 6 minus x to the 5 plus 3x minus 2. I can say it is x squared cubed minus x squared squared times x minus plus 3x minus 2. So we can say what? X squared is negative x minus 1 cubed minus negative x minus 1 squared times x plus 3x minus 2. This one I can say minus x cubed minus 3x squared minus 3x minus 1. This one minus x squared times x minus x cubed again plus 2x squared minus 2x squared, and then plus 1 minus x plus 3x minus 2. So it will be negative 2x cubed minus 5x squared minus 3x plus 3x, it will be cancelled, minus x minus 3, right? Okay, then we can say what? We can say, okay, negative 2x times, instead of x squared, we replace this, minus 5 times negative x minus 1 minus x minus 3. So it will be 2x squared plus 2x plus 5x plus 7x minus x 6x. Then plus 5 minus 3 plus 2. Agreed? Again, 2 times negative x minus 1 plus 6x plus 2. So negative 2, this one will be cancelled. 6x minus 2x, 4x. Good job. Your answer is correct. So
I did it the rough way. I replaced it on some x squared plus x is equal to negative 1.
that is also correct. X squared plus x is negative 1. Because look, you should consider this part is 0. I consider x squared is what? You consider x squared plus x, right? But let me tell you, so much faster way with same approach. X squared, we said is negative x minus 1, right?
Okay.
Now let's check next power of x. X cubed is what then? If we multiply this by x, it will be what? Negative x squared minus x. Again, we can replace x squared with this. So negative this is x plus 1 minus x, which is 1. And now we can calculate it so much quickly. Here, we say, okay, x to the 6. Let me copy this. Okay, x to the 6 is x cubed squared is 1. Minus x to the x cubed is 1. You can write x squared plus 3x minus 2. So minus x squared is x plus 1. It will be 1 plus x plus 1 plus 3x minus 2. So 3x plus x 4x. This one, 1, negative 2 will be cancelled. As easy as this. Understood? Solution 3, again, is similar to solution 2, but a bit tricky. Let me tell you solution 3. Again, you say, okay, x squared plus x plus 1, 0. Let me just check an identity. A cubed minus b cubed is what, if you want to factorize?
A minus b times a squared plus ab plus b squared.
Yes. So, do you agree when this one is 0? If you multiply both sides by x minus 1 plus x plus 1 is 0, then it will be what minus what 0?
Oh, x cubed minus
1 is 0. So x cubed is 1 and you can solve the rest like solution 2, right? Okay, maybe you ask, okay, here we could use long division or any other way. We could reach the answer in at most 6 steps. I say, okay, that's correct. But sometimes, for example, in AMC problem, the degree is not 6 to reach the answer in 6 steps. For example, the degree is 2023. Then you have to use this approach, okay?
okay.
For example, if you want to divide, for example, a problem, if you want to divide x squared, x, for example, 2023 plus x, for example, 2022 plus x to the 5 plus 5. This one, if you divide it by x squared plus x plus 1, then we can say easily it is like previous problem. We can say x squared plus x plus 1, 0, and then again x cubed is 1, right? So you say, okay, x to the 2023 is what equal to, suppose it is p of x, and p of x is equal to x to the what if you simplify this?
X.
Yes, x, because 2023 mod 3 is 1. 2 plus 2, 4
Yeah.
plus 3, 7. 7 mod 3 is 1. So remainder is 1 x to the 1. Next one is what? Is 1 because it is multiple of 3. X to the 5 is what? X squared plus 5. And you know x squared is negative x minus 1. So it will be x plus 1 minus x minus 1 plus 5. This cancelled 5. Finished, right? Okay. Now AMC problems are what? First AMC problem that you can solve is AMC. We have also this problem sometimes in AMC 10, similar problem. It is AMC 12, 20. I should check. Is it also in AMC 10 or not? AMC 12A 2022. Do you agree now we can solve this? It says this one is multiple of each of these terms. You can find remainder of each of them and solve the problem, right?
Yeah.
By the approach that you learned, you can solve this. So this one homework. How many homeworks did we have today? I think 2 homeworks. I told you. Memorize homework 1. Memorize this. This one we solved, vector theorem, or I think one homework we had. Okay, homework 2 is this one. Try this AMC 12 problem. Homework 3 is this one. Homework 3. It is AMC 12B20. No. It is AMC 12. Let me check. It is 2021, but I should check. It is fall or spring or something like that. But it is AMC 12 2021. It is 12B 2021. Let me tell you next one. Homework 4. Is AMC 12B 2022. Try these 3 homeworks. I told you all applications of this box. Remind me to tell you one more application of that next time. One more application of A of x is B of x times this. Okay? And also you can work on rest of, again, AMC if you had time. Rest of AMC 10, 12 problems. Okay? If you had time, rest of AMC again from 2023. Work on problems. And again, for example, when you ask a problem, I will tell you all properties of that. For example, you ask this polynomial problem. I told you factor theorem, and I told you related polynomial problems and background ideas are what. Okay? Okay. Any question? Okay, so have a good day.
Okay,
You're
thank you.
welcome. Bye.
Bye.